All right. Let's go over how to state relationships, okay? So, this doesn't have to do with relationships with people. This is relationships with data. So here are the basics. In science, we like to see how changing one thing can affect another thing. So we call these things variables, okay? So how one variable, if it changes, how it may influence or not influence another variable, okay? So some examples would be some real life examples in the sense of not necessarily science related, but how we could state a relationship in a day-to-day example. So how about we state the relationship between the time we spend without food and hunger, right? So the main formula here is we start by saying as our time without food increases. So if you think about it, the longer we don't eat food, right? So as the time we don't eat increases, our hunger also increases, right? Because if you don't eat food, you're gonna get more and more hungry. So as time without food increases, hunger increases as well. Let's try stating the relationship between the time at work versus time spent at home. Maybe try this one on your own. So, you probably came up with something along these lines. As time at work increases, the time spent at home decreases. Now, you may have also just said, the more time I spend at work, the less time I spend at home. That is also acceptable. That is totally acceptable. But there's a nice little formula I like to use in order to make sure that you're always stating a relationship and setting it up to get the answer right. So here's the basic formula. I always start by underlining the two things in the question they are asking for, or the two things they are asking about. Then I use this formula. As blank increases, or so as one thing increases, one of the things we underlined, then the other thing either increases, decreases, stays the same, or cycles. So goes up and down, or increases and decreases and increases and decreases. Okay? So let's try stating the relationship between time without food and hunger. So what I do is I underline the two things they're asking me for. So they're saying state the relationship between time without food and hunger. So I'll underline time without food and I'll underline hunger, the two things they're asking me about. And then I use the formula, right? So as blank, the first thing, as time without food increases. We always start by saying as the one thing increases, or as the one thing we get more of it, right? So as time without food increases, then hunger either increases, decreases, remains the same, or cycles. All right, so in this case it would be as time without food increases, hunger increases. All right, so there it is. As time without food increases, hunger increases. So now we're going to look at how we can use this with data tables, okay? So we're being asked to state the relationship between a galaxy's distance from Earth and its recession velocity. Now, you may be thinking, I don't even know what that stuff means. But this is the beauty of stating a relationship and having a data table. You don't necessarily have to know what they're asking you about, right? This could be about the amount of protons in an atom. This could be about the amount of stars in a galaxy, right? You don't have to know exactly what they're talking about in order for you to answer the question correctly. So, we're going to start by looking at one of the sets of data tables, right? The galaxy's distance from Earth, that's one of the things they asked us about. We would underline that in the question, and we would also underline recession velocity. And we just start on this side over here. So remember, we like to state relationships as blank increases, or as galaxy's distance from Earth increases. So let's take a look at these numbers. In what direction do they increase? If I go this way, or if I go this way? So down or up? So as I go down, right? So state the relationship between galaxy's distance from Earth and recession velocity. Underline what they're asking you for. So as galaxy's distance from Earth increases, let's take a look at the numbers. So as we increase from 62, we go up to 978, and we're increasing up to 1400. What happens to the recession velocity if I do the same thing over here in the same direction? So the recession goes from 1210 to 15,000 to 21,600. So that is an increase, right? So we would say as a galaxy's distance from Earth increases. So I took this galaxy's distance from Earth, and we always write increases. It's recession velocity, or from the question, it's recession velocity. What does it do? So galaxy increase, 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 increase. The numbers get higher and higher, and these increase and increase, and you just want to make sure that they continue to increase. And in this case, they do, because if it went up, 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 and then down, 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 then it wouldn't be that the recession velocity is increasing. It would be more of a cycle. Or maybe even it wouldn't have to do anything with that number if it's just random numbers. But if it goes up, 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 down, 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 up, 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 down, 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 right? Then we would be looking more at a cycle. So try this one out on your own. State the relationship between the time you stay awake and your energy level. So you should have underlined, or well, you're on a Nearpod, but the time you stay awake will fill in on the left side, right? And your energy level will go over here. So as the time you stay awake increases, your energy level decreases, or it should decrease, right? Because you're getting tired if you're staying awake. Try this on your own. Now, I just want to point out, we have a bunch of different data tables, right? We have like 6 pieces of information. So we need to really be careful about what we're paying attention to. State the relationship between air pressure and wind speed. So in this case, we're not being asked about the date, the time, the latitude, or the longitude. We're asked about these 2 columns here, maximum winds and air pressure. So if we look through this, right, take our strategy that we used before, we're starting with air pressure, right? So let's take a look at air pressure here. This is 989, 962, 955. So what we want to do is find the direction that air pressure increases. In this case, it's going up from here, right? So 921, 955, 962, 989. So we're getting an increase in air pressure. So let's take a look at these 4 over here. If I follow the same like pattern where I'm looking up, 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 right? So this is going to be an increase, increase, increase. In this case, maximum winds goes from 135 to 105, 95, 70. That is a decrease, right? So as the air pressure increases, the maximum winds decrease. And let's just double check to make sure that this works out too. This is a low air pressure, this is a higher air pressure. So as the air pressure increases, the maximum wind speeds go from 125 to 110, which is a decrease, okay? So try this one out on your own. State the relationship between the latitude of a hurricane and its longitude. So again, we're asked about latitude and longitude. There are these 2 columns here. Latitude, as latitude goes from 19, 22, 23, 24, so this is increasing. As latitude increases, what happens to our longitude? The longitude increases as well. So that is a direct relationship, right? There was an indirect relationship between these 2 numbers, right? And remember that there is a cyclic relationship where things go up and down, or that things remain the same or constant. We learned that earlier in the year, but remember, right now we're just focused on stating relationships like this, right? We can state relationships as direct, indirect, constant, or cyclic, but this is the way safer version of doing it. So as latitude of a hurricane increases northward, its longitude increases westward. So I just included that, okay, it's increasing northward, it's increasing westward. You didn't necessarily need that, but it doesn't hurt to add that stuff, okay? So try this final one. With respect to the troposphere, state the relationship between altitude and temperature. So we're just talking about the troposphere here. So state the relationship between altitude. So here's the altitude, right? As we go higher up, or as the altitude increases, what happens to the temperature? So as the altitude increases, so as we go higher and higher and up, Where does this temperature line go? So it starts at 15 at the surface, and as we go higher through the troposphere, so here's the troposphere, as we go higher through the troposphere, this line runs over towards the 0 temperature, and then at the top it actually reaches negative 55 Celsius. So the best relationship that I can state about this is as the altitude increases through the troposphere, the temperature decreases, which is an indirect relationship. So I'll give you some more practice problems with that, and you'll have a worksheet that goes along with this.